I need new ones anyways.
All right, as you guys are getting settled in, we do want you to, first, welcome to the class with Derek Argueta. We do have these survey forms for your feedback. You can either just scan it and then take the survey like on your mobile devices, or you can fill it out and then hand it to us as you go in. So I'm gonna pass them around to all of you guys, and then we'll start in momentarily. 2 minutes. So, and also make sure to use the hashtag #UtahCodeCamp throughout the whole session, the whole day. We want to rank and we want to be cool. So, all right, thanks. We're all about the swag, right? That's all these here. You know, we should have done already.
All right, so it's 10:10, so I guess we should be starting now. So welcome to Intro to MongoDB. Just out of curiosity, there's a lot of people here. Have any of you guys had experience with MongoDB prior? Tried playing around with it? Okay, cool. So we're going to got a lot of new people, which is great. That's exactly what I was hoping for. Because this is an introductory level, so if you're a Mongo veteran and you're hoping for the latest, greatest data model tips, this is probably the right thing to do that. So it's going to be fairly elementary, starting at the beginning, working from ground up. So a little bit about myself. I'm a QA Internet Domo, and I'm a CS student at BYU. And at night, I teach at Coding Campus, the Mean Stack. I have this bad problem where I have a difficult time saying no to cool projects. So I also help with a lot of startups in the area, building cool websites and mobile apps. Then here's kind of my interest areas. Heads up, I am pretty nervous. This is my first speaking engagement, so I might talk a little fast. I'll do my best to slow down and keep pace. If I start rambling, feel free to stop me. And then this is a special thanks to our sponsors that put up this event. This super cool event. It's actually my first time at Utah Code Camp, which is really awesome. So big thanks to these guys for putting this event up for us, so I can have this awesome experience. So the way that this presentation is going to go, talk about Mongo, some introductory information about it, what is it, how does it work. We'll go into some demos working directly with MongoDB, running queries against it, seeing how those work, and then also I'll demonstrate using a couple of database drivers with Node and Java, maybe Python if there's time, just to show how to work within different environments. And then if there's time after that, then we'll talk about Mongo in a distributed database, which is really what Mongo was meant for. It's meant for large data dealing with multiple servers and clusters. So that's an interesting topic that we'll try to get to. So a little background information on Mongo itself. The database, it's an open source database run by a company called MongoDB, originally called 10gen. They're based in New York City. And so since the database is open source, they don't monetize on that. Anyone can go look at the source code, contribute, download it, whatever. Where they really try to capitalize on is database support, helping large corporations set up their databases in an enterprise system, helping monitor the databases, making sure nothing goes down or nothing goes wrong. So now I want to talk about how Mongo compares to other database systems out there. First thing I want to talk about is that it's not a magical database. Everyone, I'm sure you're all aware, there's no such thing as a silver bullet in the coding world. Every tool has its own special situations. So the common thing to say in Mongo is that it performs better than MySQL. But what does that mean? That doesn't mean that everything you do is going to be faster. It just means that depending, if you use it correctly, the way that Mongo is meant to, it can perform better. So this is from a Stack Overflow post. Someone took a MySQL database and a Mongo database and ran the exact same queries against both in PHP, and he came out with benchmarks that had the same times. So he's like, hey, what's going on? I thought Mongo was supposed to be faster. And so the response was, well, it is if you use it in the way that Mongo was meant to be used. If you run the exact same queries, it's going to go out the same. Because quite frankly, if Mongo had better I/O algorithms, MySQL would have incorporated into their databases as well by now. So it's not that the actual algorithms that run the executions are quicker, it's that if you organize your data in the way that Mongo is meant to be utilized, then it can run quicker in that sense. So there's no black magic going on here. The next thing I want to brush on real quickly is the community that's out there for Mongo. So Mongo is an open source database. So you can just jump out to GitHub and actually look at the code itself. It's all up there. And one thing that I really want to zero in on and point out here is these numbers. So it has nearly 2,000 forks. This screenshot is actually taken on Sunday, by the way. So it says last commit was a little over a week ago, but I wouldn't be surprised if there was one this week. So it's a very active and lively community. And that's really important when you're choosing a tool, because you don't want to choose a tool that's going to die in a month or two. So Mongo has a lot of active development, and that's really important. Quite frankly, Mongo used to not be that good. Back in 2011, 2012, there was a lot of critique on Mongo, a lot of crashes, and just people hated it. I've talked to people at Lucid Software, they tried it, and it just wasn't working well. And the thing that I like about Mongo, the company itself, is that they're really good at responding to developers' critique and patching up their database to make it better. So, like I said, active community. And if you compare it, so this isn't the greatest GitHub repository out there, right? Linux and Git have like hundreds of thousands of stars and forks and whatnot. But if you compare it to other database systems on GitHub, take Postgres, for example, measly 400 forks, a handful of contributors. MySQL is kind of on that same level. And there are some arguments, yeah, Oracle runs MySQL technically, so probably a little not as open sourced, but still you expect to see a lot more activity on there, pull requests, issues, opening, whatnot, but Mongo is very active. The only other database I've noticed that has this much activity is Redis, which is also becoming quite popular. So here's a quick little table showing databases about popularity. This is gathered by dbengines.com. And the metrics for this was based mostly on how often is it mentioned and utilized on the web, how many LinkedIn profiles have the skill listed, how much is this mentioned on tech forums like Stack Exchange and DBA Exchange, Twitter posts, whatnot. So it's, I wouldn't say it's the most accurate measurement, but I think it gets the idea across that Mongo is rising in popularity, and it's quickly becoming a common phrase in the workplace. So Mongo company, in a few words, really like to talk about the databases in these 4 categories. It's flexible, it's powerful, it scales well, and it's easy to use. So disclaimer, I'm not trying to be a Mongo evangelist, and I'm not also a Mongo hater. That's a presentation, I'm trying to give a fair evaluation of Mongo for you guys. So this is just what, on their documentation, they describe their database as. So I would keep this in mind as we evaluate the database and kind of see, is it really flexible? Is it as flexible as we want it to be? Is it too flexible? So the first thing that would be a good place to start, at least, is how is the data stored? So when people talk about Mongo, everyone thinks first that it's JSON, right? It's a JSON store. It works with JavaScript because it's JSON. JSON this, JSON that. That's the typical thought idea. When you hear Mongo conversations like, hey, you heard about Mongo? Yeah, it's that JSON database, right? And that's kind of the end of the conversation because no one knows much more than that. But this is actually technically incorrect. Mongo does not store its information in JSON, but it's very close. So it's kind of a picky technicality. The format that Mongo does store its data in is called BSON, and it's actually a close cousin to JSON. You can think of it as like JSON++. The idea behind it is that JSON is very simple. Its purpose was to be able to get information from point A to point B on the web. So it uses very simple data types, strings and numerics, and that's about it. So the BSON project was created to provide a more powerful way to store data in a similar format. This is kind of a random side note, but so this was on Wikipedia. I saw that pronunciation. So for the longest time, I started calling it bison, as in like a kind of animal. So I will probably accidentally say bison a few times. I actually thought the sounded cool better anyways. But anywho, on the actual website, they make it clearer that it's BSON. So this is kind of a technical view of what it is. So you have your example strings on the left. That's the data that you would see. And it gets transformed to that mess on the right, which is what BSON stores it as. And so by doing all this extra work onto it, BSON can provide extra data types, such as dates and binary data objects, and store a lot more different data types. That's kind of important. So if you have a database and you want it to compete with databases like MySQL and Postgres, you need to have something a little better than strings and numerics. Quite frankly, it would be very painful to run the same regex across all your date strings to make sure they're actual dates. It'd be much nicer to have a date type that you can coerce your data as. So that's the idea behind BSON, a better way to store the data. And BSON's an open source project. You can actually jump out there and check it out if you're interested in text storage and text compression and whatnot. All right, so now we get to the actual fun part, and that is document store. So this is another buzzword that's often associated with MongoDB. It's a document store. Well, what does that mean? So there's two main components to the Mongo database system. There's documents and collections. So we'll talk about those a bit. So this is an example of a document. A document, I'm a Python developer typically, so I think of this as a dictionary, and I might accidentally call it a dictionary, but it's a JavaScript object, it's a BSON blob, whatever you want to call it. The Mongo documentation actually says things, so feel free to do this however you want. I like to think of dictionaries, they're key values. The values can be as complicated as you need them to be. It can be arrays, you can have a nested document. So a document is just a single instance. If you're a SQL developer, you could think of it as a single row in a database. That is a document. And so the next piece is collections, which is kind of obvious. A collection is a bunch of documents. So this would be like a table if you're familiar with SQL. So document stores a single instance, and a collection keeps a collection of documents. That part's pretty self-explanatory. So one thing I want to point out now is that another high, I guess, well-known aspect about Mongo is that it doesn't have this idea of schemas. These documents, you can make them appear however you want them to be. You can have whatever fields you want. If you have a collection of documents, those documents don't have to have the same field in them, which is kind of like anarchy in the SQL world where everything has to conform to a schema. That's not the case for Mongo. You can store one document that has a first and last name field, and then your next document collection can have an address and your favorite dog. It can be whatever you want. So it's kind of this little chaos going on in Mongo. So here's an example here. This is a common problem that Mongo people run into, is that they start out with some kind of data format. I don't know if you call it a schema, but a format, the way that most of the documents are organized. And then later on, they change their mind. It's like, wait a second, no, I want to do it another way. Well, there's not this concept of schema migrations in Mongo. So this is commonly run into. Well, I want to change all my previous existing records. How do I do that? So we'll get into that a bit when we start to play around with Mongo itself. This is kind of just some stuff to think about when you look at Mongo, is that if you decide to suddenly change how your data is stored, you can optionally go back and change all your previous records to reflect that, or you can somehow change your application code to handle that, to handle missing fields and additional fields. It can get pretty messy if you don't know how you want your data to be stored. So that's something to, it's good to know that beforehand, starting Mongo, at least before production, hopefully. So another concept is data modeling. It's a little different with a schema-less document store database. SQL developers love these things. I hate them. They get very messy quickly, and they're annoying to work with. Little crow's feet. I get sick of those crow's feet. Data modeling, there's two types. There's two specific categories, I should say. There's embedded documents, which is kind of the new hot thing with MongoDB, is that you can stick a document inside another one. And this is fairly revolutionary compared to relational databases, where typically you have one table of things and another table of things, and you connect them using foreign keys, right? An ID that relates to a row on the other table. Whereas here, you can stick a document directly in another, and I like that because it kind of provides the has idea. For example, I have a dog. Well, if you want to reflect that in a database, if you can stick that document representing a dog directly into the user, you don't have to make some kind of cross-table connection. And this is really where the performance kicks in for MongoDB. If you have to look up related rows in SQL databases, that's extra work having to select a specific row in the table, get that ID, then go back out and go to another table and look up the table that has that corresponding foreign key. Whereas here, the nested document is then and there. So you look at the user. In this case, you should grab the content right there without having to make an extra search. So that helps quite a bit with performance. However, according to documentation, you want to avoid this if you expect a lot of growth within your nested documents. That can lead to performance issues, actually, and also data fragmentation, which is an ugly thing. So it works great for small nested objects. In this case, if you anticipate your contact information only consisting of a phone number and an email, well, it's great. But if you anticipate your users being able to add 100 phone numbers and 100 emails, well, your model's going to start to slow down due to the excess overhead of lifting that out. So that's the embedded data model. It's pretty cool, the new feature with Mongo. And then you have traditional, what they call a normalized data model. And this is kind of what SQL developers are most familiar with. You have corresponding foreign keys. So here, each box represents a different collection. So you have a collection of users, a collection of contact documents, and a collection of access documents. And you have foreign keys tying them all together. So you can look up the corresponding contact document and the corresponding access document. So this is a cool diagram that I found, which is great at kind of explaining the difference between the relational model and the document model. So as I said, Mongo literally calls their documents things. You have a collection of things because they don't follow any format. And then the relational model, you have your traditional tables to describe your values. And in this case, it's a many-to-many relationship. So you have a table specifically matching foreign keys together. So the relational model it can be quick to get bulky, especially if you have a lot of relationships between your tables. Whereas the document model tends to seem a little more concise due to nested documents and also more powerful data types. For example, in a document, you can have an array. I know some of MySQL versions support arrays, but it's generally not common to see that. Whereas in Mongo, that's totally cool. Mongo kind of follows the idea that I have with JavaScript, and that you can basically do whatever you want, really. JavaScript is like, hey, put a colon if you want, or semicolon, or don't put a semicolon. You don't have to use the bar keyword if you don't want to. That's kind of the JavaScript attitude. I kind of feel that vibe a lot with Mongo. You can store your data however you want to. There are consequences to data formats that are not well designed, but you can do them anyways. And this is, so you don't have to read this whole thing. This is a quote from Elliot Horowitz, CTO of Mongo. And basically what he's trying to say here is that the Mongo database system isn't really anything that's entirely new. It's built upon the same fundamental concepts of MySQL and other relational databases. We just added a lot of cool stuff to a lot of pizzazz and glitter. So for example, I think towards the bottom, yeah, it says, there are a lot of things that work great in relational databases, indexes, dynamic queries, and updates, to name a few. And we haven't changed much there. For example, the way you design your indexes in Mongo should be exactly the way you do it in MySQL, with the option of just having indexing and embedded fields, embedded documents, right? Very different documents. So there's a lot of similarities you can draw. All right, take a breath because I realized I started going a little fast there. So now we are ready to start the fun stuff, which are demos. How easy is it to work in Mongo? Okay, there you go. Oh wait, there's one more thing I wanted to show. So the tool that I'm using is called RoboMongo. This is a great GUI tool for interacting with Mongo databases. If you've ever used SQL Pro or MySQL Workbench, it is similar to that. Provides a nice little user interface for your databases, so you don't have to do everything in terminal or command prompt, which is what I'm going to go to now. All right. So this is RoboMongo open. I mean, and then there, shell. All right, so this is the basic UI that you get. You just get a little terminal line where you can type whatever you want. Nice thing about RoboMongo, it's autocomplete. If you have no idea what you're doing, you can just type a dot and see what you can do. I've always appreciated that when getting started with something new. So in this case, so you have your DB object. This is basically what you run all your executions against. It represents your entire instance of Mongo that's running on your computer. So for MySQL, you have what's called MySQL D, as the daemon process that runs MySQL. Similarly, you have MongoD. I like to call it MongoD because it looks cooler, it sounds cooler. But it's the same thing. It's a daemon process that runs your Mongo database. And so that's what this is connected to and executing on. So it's taking your Mongo instance, and you have a series of commands you can run. Something to notice about the Mongo querying language, I think it has a different name, but it's very JavaScript-like, and you can actually use JavaScript logic in your queries, which I think is way nicer. As I'm personally like relational databases better, but when you have massive SQL query that you have to decipher, it can be very costly, taking up the entire workday. I remember one time at Domo, this guy came up and he was like, "Hey, you kind of know SQL, right?" I was like, "I kind of do, I guess." He's like, "Hey, can you look at this for a second?" And he showed me like the SQL query, the text file that had the query took up 7 megabytes. I was like, dude, I gotta take a whole day to look at this. Then it can start looking at the bug itself. Fortunately, the error didn't give a line number or anything, so you'd have to actually start from scratch. Whereas I think JavaScript logic is a little easier to follow. You can actually identify for loops, you can identify if statements, variable creations, all that is supported in the Mongo querying language. We'll see in a bit. So you can take your database object. First thing I'm going to do is I'm going to create, wait, actually that's not the first thing I'm going to do. First thing I'm going to do is create a database to use. That might be helpful. Create a demo database. And I think I'm too zoomed in to see it. Oh, it showed up on the other screen. Demo. Now I have this demo database that we work with. And now let's show there. And go back. Okay, so now go back to DB. And then, so first thing we do is create a collection. This is kind of like creating a table for the first time. And so you write a collection with the name. Let's call it UCC 2015. And execute that. And then just gives a little OK message, and yeah, it worked. Cool. So that's pretty straightforward. Just a function on the DB object. So if I pop open this demo database, on my collections, I have this UCC 2015 collection that I now have to work with. And you can create multiple collections if need be, kind of like how you can have multiple tables and run foreign keys across them, etc. For sake of time and simplicity, we're just going to work into this one collection for now. So going back into the prompt here. So now that I have that collection, I can run it on my database, just typing db dot, and then it's right there, UCC 2015. So accessing a collection is very straightforward and pretty easy. So now I can use the dot operator again, and you can see how the operations you can run on that collection. First thing I'm going to run, this is probably the most used command in Mongo, is find, which essentially is like your SQL select. It just shows content from that collection. Now if I run that, it doesn't show anything because we don't have any data in our collection at the moment. But if I go back and I run insert on it, The insert command takes in a JavaScript object, which it will then turn into BSON. And because it's schema-less, I can go and get started inserting whatever objects I want to. You don't have to define columns or anything. So I can just go ahead and create what I'm going to call users. So I'm going to have first name, Eric, and last name. And then also I want to see the result of that. So I'll just go ahead and put a DB find right after that, so I can see the resulting collection. And that, so now this is the resulting collection. So as you can see, the Mongo by default provides you with automatic indexing. That's something you can configure. But there's my document, my first document in this UCC 2013 collection. Just presents it as JSON. So pretty straightforward, nothing mind-blowing. In my opinion, Mongo has a much easier learning curve than SQL, especially if you have prior experience programming. I've noticed that people who don't program, say business people, often can pick up SQL fairly easily because their mind isn't clouded with programming logic. But if you have this programming logic drilled into you, I find Mongo querying to be much easier to work with because it feels like you're programming. All right. So next thing I wanted to show, there it is. So to demonstrate that programming logic, let's go ahead and create a list of more people to insert. So I'm going to call it user list. So I'm just going to create an array here. And I'll just insert, say, 3 users. So let's go and grab Elon Musk. One document. Whatnot. Oh. If I had misspelled last name, that would have worked. It would just created a field called LSAT. Really difficult to work with. So that's one of the things you got to be careful with in Mongo is, like I said, it lets you do whatever you want. And one more, still 9. So there's an array of users I want to insert. And when I was actually first playing around with Mongo, I don't know why, but that's the idea that I had to insert them individually. So I actually made a for loop that iterated through the array and inserted them. It worked perfectly fine. But Mongo can insert documents and an entire array of documents as well. So we're going to go ahead and do that instead. So we'll just insert list. Okay, no typos. Cool. Let's run that. And now we have our document. Oh wait, I typed Tony Argueta. I just realized that. Whatever. He's my brother now, apparently. Yeah, let me see my real quick. Awesome. All right, so yeah, so there's our entire collection. It has 4 documents. Those documents all have a first name and last name fields. There's on the slides, I'm not going to talk about though, but it's highly recommended for you to have kind of an inferred schema on your database. You don't want to have documents with mismatching fields because that's going to be really hard for your application developers to work with. They're going to expect first name and then it's not going to be there. Or they'll pull an entire document with a bunch of random fields that they weren't expecting. It can be very difficult to work with. And there's actually some database drivers out there that have you use a schema. They kind of add a schema on top of Mongo in between your application and your database. So that way, there's no, it's predictable. That's what your database is predictable. And that's something you really want in a program. You want to be able to predict what your programs do. That's kind of a key thing. If you don't know what your program's going to do, that's a really bad sign. And you probably should start writing tests. So that's kind of a tricky thing with Mongo, that if you don't have an enforced schema or if you don't make it clear what your database model is, things can go awry fairly easily. Mouse, there it is. Okay, so the the next thing we want to grab. Whoops. Okay, there we go. Private. So I'm going to demonstrate a little more on the querying language. I'm not going to go too much into it because there's an entire API documentation out there on the Mongo site that you can refer to. Just kind of give you an idea of how it feels, how it works. So here is a conditional find. Because JavaScript objects by themselves are pretty static, there's really not much dynamicness going on within a JavaScript object. Mongo adds in these extra operators. You can identify them by the $sign that they start with. So in this case, we have an OR operator. And what it does is it takes in an array of conditions. So we're checking if the first name is equal to 2, or the last name is equal to must. So I probably should have clarified this earlier, but we're using the same find function that I was using before, but now we can pass in a dictionary of parameters to search by. And that should start with that. Sorry, ahead. But you take out the fancy stuff and just put, say, first name, Eric, and run that. We're running 2 finds. And I lowercase my name. There we go. So you can put in a JavaScript object representing things you want to search by. So then back to the example I was trying to demonstrate earlier, with the OR. So this kind of way to provide some conditional logic that OR and greater than, less than, a bunch of other conditionals that they added into Mongo querying language to make your queries, to allow them to be more complex. So searching this brings Elon Musk, because his last name is Musk. And easily I could search this to and then that doesn't return anything. This man's name is 2 Musk.
It's
kind of
case sensitive, right?
Yes. And there are other configurations. You can add an additional JavaScript object specifying certain parameters to make it case insensitive and whatnot. This is kind of a bare bones example, but there are extra configurations you can put on top of your clients to make them more tailored to what you need. So this is kind of the basic querying example here. And keep using the nuts. So the next thing I could show is updates on an existing record. Let's go back to UCC.1. And that brings up all my documents again. So now let's actually modify one. Actually, yeah, let's modify one. So I have a couple of these saved on my other screen just for the sake of time, so I can type them. So in here, so you have your first. So first of all, I'm using the update function on the collection. That function takes in 2 parameters. The third one is optional. That's kind of your configuration object. You can pass some extra stuff. So the first parameter takes in is an object specifying which one to grab, which document to grab. And the second parameter is the object that specifies your update operation. So here we're running the set operation on a document that has the first name Derek. Let me change that to G. Actually, let's do that. Let's use the update operation to change my name that's properly cased. So inside the set block, I can choose the first name field and set it to capitalized Derek. So that's everything that you need to update that. And that, now you can see my first name is now capitalized. So match everyone else's. Yeah.
So is every property on a BSON object indexed, or do you have to choose what's indexed?
I don't know much detail about indexing. That has to do more with how Mongo configures it. And there is, you can configure the indexing however you need to be. They have a whole section of documentation about indexing. I believe by default everything's indexed. Yeah, that's a good question. Yeah, disclaimer, I'm not a Mongo expert, so yeah, check that on that. So that's the set operation. Likewise, you can use the set operation to add additional fields onto Mongo, or sorry, a document. So if I would say name, full name there. And run that. Oh, sorry, it's not finding my name anymore because it's not. Okay, so then that adds a field to your document. Like I said, it's easy to do whatever you want. You can add fields as you need them, remove fields as you need them, but that is very dangerous and will probably make your application developers very, very angry. So don't do that. And then likewise with the set operator, it has an unset operator used to remove fields from a document. The thing about the unset operator is that the value you put here doesn't really matter. That's kind of standard, just put an empty string there. But that should get rid of that name field. Yes?
And if you hadn't specified that over there, just update all of them.
You can update all of them. So yeah, actually going to do that right now. For that, you will need to add a small configuration in the third parameter. Let's go ahead and add back in full name. But I don't know, bar. So then you just remove this filter here and add a third parameter here saying that it's okay to update multiple instances. So yeah, there's a multi-flag that you can send your configuration, say it's okay to update multiple objects, and as a result, all of our objects, all of my objects have a full name of foobar. So likewise, you can do the unset with the multi-set to true, and that'll remove all the name attributes from every document in the class. Yeah.
So those empty braces have just applied everything.
Yep, matches everything.
And if you don't have the multi-true flag, then what's it do?
Then it just updates the first one it runs into, just in case we mind. Yes.
Is there a support for wildcard search?
Sorry, there's a.
Like in the find? Is there a
Yes.
support for the wildcard search?
I think there's an extra configuration I haven't done with wildcard. We can try it out right now. See if it matches. Assuming you would be. Actually, this is doing fine. Matches K. I think by default not, but I think there's a configuration that you can do to add wildcard support. I'm sure there is. I'm sure that was mentioned thing.
You can use regular expressions by putting slashes.
What was that?
You can use a regular expression. If you put a slash instead of quotes around it, that means it's a
Oh.
regular expression.
Gotcha. Yeah.
Word slash.
Uh,
Remove the quotes.
That's something to look into. Yeah, I'm sure it's there.
Yeah. The slash star, I thought it was a comment. That's what happened.
Yeah, it did. So that's kind of the basic get a feel for the Mongo querying language. As you can see, it's very powerful. I like it a lot. I wish you could use it for relational databases, just because it's kind of nice to have that programming logic that you can flow through and follow. You can set variable strings as your conditions and pass those into your queries, and so you have named conditions, which would be really nice. I think there's one more query that I had prepped run here. Yes, I do. Okay, so here's a query where we have two conditions. So within a search, if you have access to the this operator, you can specify specific details on the certain document you're looking at that moment. So condition 1 is based on last name. This will check if the last name exists. As you might presume, this is a very common thing to do when dealing with Mongo, checking if the field is actually there before trying to run anything on it. Then the second condition is that if it does exist, well, the last name, the length of it, string greater than 4. So now just combine that to a main string called main condition. So we have to define function where you use the where operator to match that. So from that, we get Derek Argueta and Tony Argueta, because both of those have last name Mongo characters. So in here you can basically put standard JavaScript for string manipulation, string manipulation, things like that. That's kind of a little bit on the where operator. So that's most of what I have prepared for playing around with Mongo directly inside RoboMongo. My guess is that you probably won't be spending all your time running direct queries. So now I'm moving on to example using Node.js. Oh wait, sorry, but yeah.
Okay, so does RoboMongo install Mongo as well? Is it
No. So yeah, it's a good question. I install Mongo separately and then run the daemon. Then you can connect to the daemon using Robo. And then so that's what I got to plug in when the when it started, and it's on the verge of death now. So great. There's power sockets right there. By the way, I think Mark Anthony handed out speaker evaluations. I really appreciate those. As I mentioned, this is my first time. So I love feedback, critique, bring it on. Yeah, I look forward to future opportunities to speak. What do you do? Wait, that's not what Twitter right now. Okay. Okay, cool. I have power again. So there's 20 minutes left, so I'll probably skip or just do a very dry run through of the Java implementation, just because I want to chat a little bit about Mongo in a distributed environment, which is really where it thrives. Quite frankly, if you're using Mongo on a single server system with only a couple megabytes of data, it's probably a little overkill that you actually need. In that case, it might be easier to just work with a relational database. But we pull up, beautiful sublime. Okay, and then Python will pull up. And one thing worth mentioning here. So the tool I'm using is this beautiful furry little animal called a mongoose. So there's a tool out there called Mongoose for Node.js. It is a database driver for Mongo that you can use to interact with the Mongo database. It's something that I want to point out here. So this is where they mentioned the ugliness of dealing with unknown data in Mongo. This is why they enforce a schema when you use Mongoose. So they're saying here, writing business logic and validation code is tedious, so we just have to use a schema and we run all your queries off of that schema. So it's kind of a nice thing they add. I like it probably because I come from a relational background, so I'm comfortable with the idea of having that comfort that yes, this is the data that I'm looking for, or it will take this data or won't take this data. It's always a nice feeling when you can anticipate. And what is that? Okay, so here's the Node.js demo that I put together real quick. So you have to npm install Mongoose for those of you familiar with Node and no npm. So Mongoose install that. And then you have a URL scheme that you pass in to identify, first of all, where your database is. Well, in this case, it's just running on localhost, and the name of your database, which in this case is called demo. And this is kind of just some validation code here. So I'm going to run it and just say database or DB open, just so I know that yes, the connection was established correctly or something went wrong. The real magic starts here. So Mongoose, you can define a schema. In this case, it's the first name is string, last name string. And then this is kind of redundant because I did it twice. But you can specify which collection this document belongs to, or the schema. You really only have to put it in one place. I don't know why I still have it in 2 places, but I'll still down there. Okay. Okay, so here's the schema right here. And then after that, you turn your schema into what's called a model. This is where it actually gets useful, I should say. So your schema defines how it looks. You can pop that into a model, and then you create instances of that model, which you then work with, kind of like an ORM, an object relational mapping. It turns your data into a JavaScript object, and vice versa for easy translation. And because Mongoose stores in BSON, it's pretty trivial to get JavaScript. So here's where I create an instance of the model, and I call that user. So when I run all my further executions on this collection, when I want to create new users, delete new users, update users, I'll use this user object, which has that compiled schema. So it knows what it looks like, it knows what collection it's in, has all that metadata there that I've already configured. So the first operation that I run on it is a find, and I just pass in empty curly braces to indicate that I want to find all the documents in that collection. That's pretty straightforward. I don't run this once I go through the code. The second one is specify find. I search for a document where it has a first name attribute of Bill. That should return Bill and I. And then here I insert a new user. So to create a new user, specify what the first and last name should be, and then hit .save, and you can have that callback there for comfort, I guess. That's the gist of it. So running this real quick. There you go. Okay. So there's a lot of results there. So you see that first DB open there, that indicates, okay, yeah, it's a successfully made a connection. Then this first array, should just pull in all of the users that are currently existing in the database. Then you can see this for science, that means that the Brian Green new user that I created was correctly created. And then this find was from when I searched for first name by Bill. This is one of the reasons I don't like nodes. All these callbacks run asynchronously, and so you kind of get a random representation of what they're run in. And hence the term in node callback hell, where you have like 20 callbacks nesting each other. Yeah, so that's the basic screen. That's a basic implementation of Mongoose to interact with your database. From what I've seen, this is a lot simpler than a lot of SQL configurations. Yeah, that's what I have to say on that. So that's pretty straightforward. And then put together a quick Java demo, which I can run through. And the whole purpose I'm using 2 different demos is because I'm trying to cover like 2 different classifications, programming languages, figure out how to move this one to okay. IntelliJ. So likewise with Java, so MongoDB actually makes their own jar that you can use as a Mongoose driver. You just download that, configure your library paths, whatnot for Java, and provides the flags object you can use. So, so creating this is the Mongo clients to use for actual connection. Then you can specify which database to grab, which collection to grab. It's very similar to how that was a node. And so they provide you with all these necessary objects you need to interact with the database. So one thing that's typical in a SQL setting is that you typically have in your ORM these data models that describe how your tables look, and those are the objects you work with. Since your objects could look like anything in Mongo, there's no telling what they have. Instead, you use these wrapper objects called basic DB object, and it's essentially a wrapper around a hash map. So you essentially use a kind of key value type of store. And here we're creating a basic object. Another one. This is the one I'm looking for. So here, create a basic object to start with. He has a first name of Jimmy. And then if you want to add more, then you just do .append. You can add as many keys and as you need to an object before you save it. So that's the implementation of Java. And run this real quick. Pull up the result here. Okay, so here's the result of what was being run. So the first thing we did was we just printed all the documents. So I just find and then I converted that into an array. Sorry, the text is a little small. Yeah. There we go. Sorry, that's actually the second thing. The first thing was I printed out the available databases using this little code up here using get database names from Mongo clients. That's kind of if you just exploring the database. Hopefully you already know what database you're working with if you're using Mongo. But if not, you can list the databases. So a lot of bases have the same thing we did in Node here. So here we are searching for an object. So if you want to do a search, you just create an instance of a basic DB object and pass that into your query saying, find me a document that matches this basic DB object, this hash map, and those results out. So there's really nothing new here to show. It's just if you're a Java programmer, it's what it looks like for you, since Java is Java. Let me see that time. Okay, cool. 10 minutes. So any questions about the implementation themselves? I wasn't going to do anything too complicated because all the documentation need is up online on these drivers. I recommend Mongoose for Node. It's very nice. For Python, there's one called PyMongo. It is right here. Probably not actually going to run it. This is what it looks like. So you just import, import from PyMongo. You can pip install it. Same thing over and over again. Just define your data or specify your database, specify your collection, and then you have these .find, .insert operators you can run. So it's very nice to get just up and running with Mongo very quickly.
Does it, like to your earlier point, does it map those to dictionaries on the Python side, or is it?
Yeah.
It does.
Yeah, so here with this new user, I actually created a dictionary here and pass that in as the document I'm creating, so just map that over to BSON and stores that. So yeah, it's very easy to work with in JavaScript and Python. Java might be a little more cumbersome, but still fairly straightforward compared to writing out SQL queries and using whatnot, or depending on what framework you might be using. I'm not a big Java developer. So going back here, so that was what I had for the drivers and kind of an in action of Mongo. Any questions about that? No? Cool.
If you're moving from a relational database to this type of system,
That can be painful.
Relations.
Yeah, so
Find it out, or
what was that?
do you make it all flat, or do you still have relations going on?
So you can start relations going on. In some of the earlier slides I had, you can, so here in this example, we have keys tying across between collections. So that's kind of one of the things that the CTO is saying is that there's a lot of concepts that bring over MySQL. For example, a multi-table database in MySQL can be translated into a multi-collection database in Mongo. However, there may be options where you might have to switch to an embedded document rather than a collection for a foreign key if the situation fits. But yeah, so conceptually wise, it's pretty trivial. Your tables translate into collections, your rows translate into documents. Actually doing it is a little painful. I'd probably write a Python script to do that, but yeah. There's a few minutes left, but one thing that I really wanted to get to before closing is distributed systems of Mongo, because that's really where Mongo thrives. If you're, like I already said, if you're running a single server, Mongo might be a little overkill, and it's just really like working with Mongo. But really the purpose of Mongo is that it works well on multi-servers. That's something that SQL can sometimes struggle with when it comes to completeness and availability and things like that. So one of the major concepts I want to cover is replication, which is pretty straightforward. Basically, you can configure your Mongo instance, your daemon, to interact with other daemons to replicate your data set on other servers. So you have backups. That's basically what that means. You have several backups. So you have a primary Mongo daemon, which accepts read and write requests. and on a heartbeat you set, I think scanning is like every 6 seconds or so, it'll replicate that data to secondary servers that your data is secure in case anything happens to your primary data. And you can also configure your secondary servers to also be able to do read requests. So that way you can kind of leverage that off of your primarily for storing data, and you can configure it to read off of any of the data sets that you need. In the event that your primary does go down, Mongo has this built-in thing called automatic election, where your secondaries elect a new leader in a sense. It's a pretty cool idea. It's kind of like teasing with AI a bit. They basically pick the best secondary server, call it the primary, and then the system just keeps going. I think the proper thing has this automatic failover, so if your primary fails, you keep on going. And this is something that really made a big stride in Mongo, because previously, in previous years, I was actually talking to someone who's running Mongo on multi-servers. The problem they had is that when one of their servers crashed, the entire cluster went down, which is terrible for a distributed database, but that's been fixed. They have this new system up and running, and what I've been finding online, it seems working well. As I mentioned earlier, when trying to give me fair criticism to Mongo, I actually couldn't find much criticism in recent years. Like all the angry articles and rants have been like 2011, 2012, and then it's kind of just died down. So that's kind of interesting. The second thing I wanted to talk about, and this kind of be the last major topic I'll go over, is sharding. So this also ties into large distributed databases, and this is really where data gets distributed, I should say. So sharding is where you take a large data set and spread it across multiple smaller data sets. So in this case, you have 1 terabyte data set, so you split it into 2 instance gates across multiple servers. The actual configuration for that in production looks something like this. So this is what a sharded cluster looks like. You have as many routers as you need. So these routers will accept your actual operations and map them to different shards in your cluster. You can have as many shards as you need to the actual storing of your data. So as your data grows, you can just pop in another shard. And then you have config servers which store the metadata about your cluster. I think Mongo enforces at least, well, not exactly 3 config servers. The reason for that is in case any of your config servers go down, you have more config servers available so that your cluster can keep on running smoothly. You can have as many routers and shards as need be. So this kind of ties to the idea of vertical scaling versus horizontal scaling. Mongo heavily encourages horizontal scaling, which is the idea of just popping in more servers as needed, as growing horizontally, versus vertical scaling, where if your server is starting to lag and run down, you add new RAM, bump up the hard drive. You're building up on that single server itself. So that's vertical versus horizontal. And Mongo pushes for horizontal scaling. I don't think I had anything else to say about that. So in your test configuration, you can have 1 config server, but when you push up to production, you need 3. Yeah, that's what I had to say on that. So these are a couple of learning resources, getting better at Mongo. I really like MongoDB University. They have courses specific to different languages that one learns. If you're a Python developer, they have a free course available for interacting with Mongo and Python. If you're a Java developer, likewise. In my opinion, however, the best teacher will always be trial and error. Just go ahead and jump into it. Something breaks, cool. You now know that that doesn't work. So I recommend these resources needed. And also just give it a Google search. We live in an awesome era where anything typed in Google will bring up something promising. And then lastly, so this is some contact information if you have any questions about me or whatnot. Yeah, that's everything I have prepared for you guys today. Real quick. I do have a few minutes left over if you have any questions or if you want to leave early, grab something, go back and whatnot. But I think that's it. Again, big thanks to our sponsors. And thank you to all you guys for coming. Yeah. This one?
Yeah, so when you guys are data sharding, and you add a server, does it automatically shard?
If you have a replication set up, then your replication uses the combined replication already. So that way you can get more data that is sharded and put replication on top of that, so you have to manage that data. basically within the process and add new shards. Work on what we did and just top of that, you let me add shards. Oh, and feel free to grab stickers. If you like stickers, we have Mongo stickers from MongoDB. I like stickers a lot. They come on my laptop. So.
But I never figured out what they're actually about.
Yeah, so it's a business intelligence. Hey, Sarah, right? Yeah, nice to meet you too. Yeah, so Github is business intelligence. Basically, CEOs want to know about the company, need ways to make quick decisions. So you write a dashboard that connects to data sources, spreadsheets, SQL databases, so have an instant view.
Will you be sharing the presentation?
Yeah, I can put it up. See.
I can email it to you.
Yeah, if you have an email or something, I can send it to you.
Yeah, sure.
I'll just write it.
Yeah.
Yeah, that works great. I'll send it to you. Yeah.
It was nice talking.
Cool. Thank you.
Thank you.
This is my first talk, so I was pretty nervous, but thank you.
Thank you.
You're like a Googler, that's what you look like. Google like conference speaking.
That'd be fun.
Good job. Appreciate it.
Thank you. Exactly what I'm making with the shirts. I have a Mongo shirt. I wanted to wear that.
Why didn't
They're
you?
like, hey,
Why aren't you wearing
by
my
the way, we
shirt?
have these logos.
I came in and they said we don't have any more.
Oh, because you came late.
You can go run and grab it. 'Cause you're
Nope.
You didn't come to the dinner last night.
Dude, I found out last night I had